right, guys, so here we are, we're getting started. Just a heads up, I'm trying to make this video short, so if you need to pause because I'm going too fast, make sure that you have plenty of chances to do that. All right, last day, 10.3, day 3, rational problems. These first two problems that I'm working on are just straight solving problems. So I'm finding the LCD here. And the reason why I'm bringing this up to you guys is because we're going to have extraneous. So if we look at what the denominator is, I know that x cannot equal a -3 or a 2. So we're going to go ahead and multiply both sides by the LCD. Remember, on equations, when I multiply, they cancel out. So this is going to be just x minus 2 squared and then a -1 times x plus 3. Now remember, on the other side of the equal sign, all of those cancel out. So that's just going to be a 25. Now I'm just foiling, distributing, and combining like terms here. Remember, on a quadratic, you have to make it equal to 0. So that 25 got pushed over, and that's how I got a -24. This is factorable. Let's factor this. There you go. X equals 8 and a -3. But remember, we said in the beginning that x could not equal a -3. Let me move the screen down in just a moment. Okay, so take a look at this. This is all of the work. I know I went real fast, but 8 gets inside the braces because it's real. We want that answer. -3 is in parentheses. It was extraneous. We could not use -3. All right, let's take a look at next example. So again, over here on the right side, I'm just going to factor that. And at the same time, remember, x cannot equal a -5 and x cannot equal a -1. So here I'm distributing the LCD. Remember, no fraction bars anymore. If you got a fraction bar, you did something wrong here. Just foiling out and distributing. All right, so remember, it's quadratic. It's got to equal 0, pushing everything over to the left. And y'all, I think that's factorable. Pretty sure that's factorable. So if you notice, I'm doing my little shortcut. I'm going to divide by the a, simplify those fractions, and that's going to be my brand new binomials. So remember, I got x equals a -1 and 3/10. X could not equal a -1. So I'm using my symbols to show what is the real solution and which one is the extraneous. Okay, example 3. Y'all, this one's pretty important. Please, please, please pay attention. All right, a sink can be filled by a pipe in 5 minutes, but it takes 7 minutes to drain this sink. So this is a work problem. Let's read the question. If the pipe and drain were open, how long would it take to fill the sink? So T is going to stand for time worked together because they're both open at the same time. Now listen, it's being drained. If it's being drained, that means the water's being sucked out, which is a minus. So this is the first time we have a minus in our work problem. One sink, one task, it still is going to equal 1. So let's multiply it by the LCM. Kind of clean up this work here. So how long is it going to take? It is going to take 17.5 minutes. Remember, it says minutes. And just make sure you write it in words. Example 4. So I'm going to show you I did all this work, and then you're going to see it's just a big waste of time. But here we go. A water from a tank is being used for irrigation at the same time that the tank is being filled. The inlet pipe can be filled in 40 hours. So the inlet is the water pushing it into the tank. That takes 40 hours to fill the tank all the way to the top. There's 2 outlets, which means there's 2 drain pipes. And the first pipe can drain it in 5 hours. The other pipe can drain it in 8 hours, respectively. How long will it take the pipes to drain the tank if all 3 are open? So T is going to stand for time together. All right, so the T over 40, that's the inlet pushing it in. 40 hours to fill the tank. Now we're going to subtract the outlet. So there's the first out pipe. There's the other out pipe. You got one job, one tank. So we're going to set it equal to 1. So it is at this point in time where logic should kick in here. If it takes 40 hours to fill a tank and it takes only 8 and 5 hours to drain it, is the tank ever going to get filled if all of them are open? No. So logic should absolutely tell you this problem is impossible to solve. Watch what happens when we solve it algebraically. So again, no more fractions. I cleared out with the LCD. Y'all, t minus 8 minus 5t, all those t's are a negative number. So we're solving for time here. And when we solve for time, we get a negative answer, which is impossible. So there is no solution to this problem. If all 3 pipes were open, it would never fill. Okay, so now it's time for your self-check. Super quick. Your self-check is this right here. If that is backwards, I'm sorry. Remember, it's no homework night, so it's due at the end of class. And I'm going to stop talking so you can get to work now.